Welcome to section 7.2, where we will be discussing roots. Now, before we discuss roots, I do have to take a moment and talk a little about marriage. Now, I know that many teachers talk about marriage on campus, but I need to talk about marriage to help prepare us for this mathematical lesson today. Now, you might say, what does a math teacher have to say about marriage? Well, I just want to share a couple things. First of all, marriage is the most important covenant that we get to enter into in this life, and it is a key part of the plan of happiness. Even Jesus Christ taught about marriage. He said, "But from the beginning of the creation, God made them male and female. For this cause shall a man leave his father and mother and cleave to his wife, and they twain shall be one flesh. So then they are no more twain, but one flesh. What therefore God hath joined together, let not man put asunder." I love this scripture because it talks about the key steps for getting married. And some of you might need to know this. Let's take a look. Let's dissect this scripture a little more. First of all, step number one is you've got to find someone to love. Find someone to love. There are many people out there, and this takes time. Don't rush this. It takes time. You're going to find someone. You got to go on dates. Sometimes we try to make this happen before or unnaturally. Just be patient. It will happen, okay? First of all, find someone to love. Step number two, it says that I love this part here, that they shall be one flesh. In other words, they get married. We are blessed to have the priesthood and holy temples where these sealings can happen. And I just want to share my testimony that I know that the priesthood authority and what we do in the temples is of God, and it brings great happiness to us. So step one, find someone to love. Step two, you get married. You get married and you become one. Become one. Step three, you leave your father and your mother. You move out of the house. Move out of house. These are the key three steps in this scripture. And it's also the three key steps for our math lesson today about roots. Let me show you why. Most of you are probably familiar with simplifying roots. For example, the square root of 25, well, that just equals 5 because we know that 25 is 5 squared, and the root cancels the power, leaving us with 5. But we can't really do that with the square root of 20. I don't know what number times what number is the square root of 20. We could bring up a calculator and type it in, square root of 20. And when we do that, we get this decimal, 4.47213, blah, 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 blah. The square root of 20 doesn't have an exact root. In fact, the square root of 20, if you remember back in chapter 1, is actually an irrational number. Irrational. That means that it goes on forever. Goes on forever. And can't be written as a fraction. Can't be a fraction. Just like the number pi. It's irrational. So the square root of 20, we don't know exactly what it is. Well, we found out its decimal value here, but we'd like to simplify it. Now, to simplify a root, we're going to follow our 3 steps of marriage here, okay? Step number 1, you got to find someone to love. So we're going to break this number down into its individual factors, its individual people. Let's do it. Let's see, 20 breaks down into 2 times 10, and 10 breaks down into 2 times 5. So that's step 1, break down the number into its factors. You're going to notice that some of these numbers are going to have someone to love. Look, we just made a match. We've got a match here. These 2s, oh, they just found each other. They have someone to love. So these 2s, they're going to get married and become one. We marry them, they become one, and they move out of the house. Now, we're going to call the root the actual house. So the 2s, because there's a pair, they get married, they become one, they move out of the house, And then whatever's left over inside, notice the 5. The 5, he doesn't have anyone to love. And so therefore the 5 stays inside. He doesn't have someone to love. And that is how we simplify a square root, a root function. Let me just show you. If we were to type this into our calculator, 2 root 5, you'd actually see that we get the same answer as before. And so these are equal. Root 20 is the same as 2 root 5. It's just that we simplified the root 20.
To the boards!
Okay, so now it's your turn. Go ahead and pause the video and let's go to the boards. Try these 3 problems, breaking them down, finding the couples that can get married, and then marrying them and moving them out of the house. Good luck. Okay, let's see how you did. Let's go ahead and work on seeing if we can find anyone to love here. Let's do it. I love this song. Find me somebody to. Let's do it with this number 75 here. Here we go. We're breaking down 75. I think of 75 as 3 and 25. And 25 is 5 and 5. Is there anyone to love? You bet. These 5s are the same. They're going to get married and become 1. They move out of the house, so the 5s come out. And the 3, he doesn't have anyone to love. And so therefore, we keep the 3 inside the house. Okay, let's try this next one here. Square root of 180. I see 10 and 18, which is 2 and 5. 18 is what? 2 and 9? And 9 is 3 and 3. Huh. So on this one, it looks like we've got lots of weddings going on. Man, it's like a Saturday at the Rexburg Temple. Look at this. The 3s are getting married. Oh, I better draw my house here. They move out of the house. The 2s are getting married. They become 1 and move out of the house. And again, this 5, sadly, he's by himself. He doesn't have anyone to love. So the 3s and the 2s moved out. And so our final answer on this one becomes 6 root 5. Hopefully we'll find someone for that 5 to love in a future problem. But the 3 and the 2s, they get married, they become 1 and move out. And then we just multiply them together. Okay, let's do this 392 here. We're going to have to break that down. So we can divide out a 2, and that gets us 196. Divide out another 2, that gets us 98. Another 2 gets us 49, and then we've got a 7 and a 7. Okay, so I need to draw a house here, and let's get some weddings going on. This 2 marries this 2, moves out of the house. The 7s, they get married, become 1, move out of the house. This 2 sadly doesn't have a pair, and so he gets left in the house. He doesn't have anyone to love. And so here we're going to multiply the 2 times 7, 14 root 2. Me. Oh yeah! Okay, so that's how we simplify roots. Now it is possible to simplify roots of higher powers as well, but that would mean if for example, a cube root of 54, we could simplify this as well. The only issue is that, well, and this may not work very well with marriage, but now to be able to find someone to love, you would need a set of 3 to marry them and become 1, which, yeah, we shouldn't talk about. But, okay, maybe these rules don't apply anymore, but that's how we would do it. So if we break down the 54, it would be 2 and 27. And then the 27 is 3 and 9, and then a 3 and 3. And notice that we have a set of 3 here. So those become 1. They move out of the house, and we're left just with a 2 inside. So the answer here would be 3 cube roots of 2. You guys try it now with question number 4. I'd like you guys to find the 4th root of 80. Go ahead and pause the video now and see if you can simplify the 4th root of 80. Good luck. Okay, so let's see how you did on this problem. 80 breaks down into 8 and 10. 8 breaks down into 4 and 2. 10 breaks down into 2 and 5. And 4 breaks down into 2 and 2. Sometimes you might want to cross out the things that you've already broken down if these previous things are messing you up. We would need a set of 4 to be able to get this set out of the house. I've got 1, 2, 3, 4 twos. We combine those together, they become 1, they move out, and left inside is this 5. Don't forget to put the 4th root. So our answer here is 2 4th root of 5. Love. Oh yeah! We can also deal with algebraic expressions. Now it's no longer just a number in the root, but we've also got letters. And so the same principle is going to apply here. We're going to break the number up. 8 breaks up into 4 and 2, which is 2 and 2. We also have 4 x's, and you could actually draw them all out if you wanted to. X to the 4th is x times x times x times x, and y to the 5th is y times y times y times y. Oh man, this is kind of the long way to do it, but we'll do it. And z, I would not need 9 z's, 4, 5, 6, 7, 8, 9. Whoa, that's a lot of numbers there. Okay, and so what we would then do is circle our pairs so that we can marry them and move them out of the house. So notice here we've got 2's. So let me draw so a 2 moves out. Here we have a pair of x's and another pair of x's. So we actually get, that becomes 1 and moves out. This one becomes 1 and moves out. So we're left with x squared. Let's see how many pairs of y's we'd have. 1, 2. That would get us 2 pairs of y's moved out. We'd have a y squared that moves out there. And for z's, we would have 1, 2, 3, 4 z's that move out. And so it would be z to the 4th on the outside. Now we've got to figure out what didn't get married, what gets left inside. Well, it's that 2. All the x's are gone. This y didn't get married, so they stay in the house. And same with this z. And so this here is our final answer. 2 x squared y squared z to the 4th, square root of 2yz. Now, you don't have to write it out every single time. That seems a little crazy, especially if it was like square root of z to the 101. You wouldn't want to write out 101 z's. Basically, what you would need to ask yourself is how many pairs do you have? How many pairs? And if you want to know how many pairs, you would just divide the number by 2. So 101 divided by 2 is 50 with a remainder of 1. And so we would have z to the 50th move out, and 1z, that remainder, he would stay inside. So you don't have to write them all out because you would not want to write out 101 z's. That would take forever. Okay, so let's give you guys a couple problems. Okay, so here are 3 problems for you to do. These are algebraic now. They also have numbers in them. So you can do it the same way. Do the numbers and the letters. Find someone to love, get them married, move them out of the house. Go ahead and pause the video now. Good luck to you. Okay, let's see how you did. We've got the square root of 45x to the 7th. I'm going to break this down into 9 and 5 and 3 and 3. I love this song. We do have a wedding here. Those become 1, move out of the house. The 5 stays inside. X to the 7th, well, that would be 7 x's. I don't know if you drew them out. You could if you wanted to. We'd have 1 pair, 2 pair, 3 pairs. They move out, become 1, and there'd be this x that's left inside. So there's our answer for that one. Let's do this one here. 200 is 2 and 100, which is 10 and 10. I'm actually going to stop there because those are pairs, and so that's cool. So the 10 would move out, and left inside the house would be this 2. Then we have to see how many pairs of 20. I'm not going to write out 20 x's. I'm just going to take 20 and divide it by 2. I get 10. So I'm going to get 10 pairs with none left over. I've got 51 y's. 51. How many pairs can I get? That's 25. So I'm going to get 25 pairs of y's that become 1 and move out with a remainder of 1. So there's 1 y left inside. Okay, this was a challenge problem, number 7. I wonder how you did. It was a cube root. So with a cube root, you got to find sets of 3. Let's see. 24 is 8 and 3, which is 4 and 2, which is 2 and 2. There they are. I see them. Those guys become 1 and move out. The 3 is left inside. Ooh, x to the 9th. How many sets of 3 would I have? You could write out 9x's if you wanted to, or just divide by 3. We would have 3 sets. So I get x cubed. How many sets would I have? How many sets of 3 would I have with 16? 16 divided by 3, that's 5 with a remainder of 1. So I would have 5 sets of 3 that become 1 and move out, with 1 left over inside. And don't forget to put a 3 here to remind you that it's a cube root. Now, we started with a cube root, we'll end with a cube root. Excellent, nice work with these. So we just got done simplifying roots. We now need to learn how to add and subtract roots. For example, the square root of 8 plus the square root of 2. Now, a lot of people would jump to the conclusion and say, oh, I know, it's the square root of 10, but that is not right. You can't do that. We're not allowed to add insides of roots. In fact, when you add things together, they have to be like terms. Must be like terms. In other words, they gotta be exactly the same. So to add or subtract a root, step number 1, you're gonna wanna simplify both roots. Simplify. And then combine like terms. Combine like terms. So let's take a look at this. If I break down 8, it's gonna be 4 and 2, which is 2 and 2. So we got a wedding here. And so I'm left with 2 root 2. These guys go inside because they didn't have someone to love. Plus, well, this is just a root 2. This one doesn't simplify because 2 doesn't break down into anything. So we're left with 2 root 2 plus root 2. Those are like terms. If you had 2 roots plus 1 root, you would have 3 roots. You could think of a 1 being here if you wanted to. But basically, we had 2 root 2 plus another root 2 is 3 root 2. Remember that you must simplify first and then combine like terms. If they're not the same root, root 3 plus root 2, then you can't add them. They gotta be exactly the same. They gotta be like terms to be able to add or subtract. Okay, now it's your turn to give an addition and subtraction problem a try. Let's go to the boards. Pause the video now, give these ones your best shot, and then unpause it. We'll see how you did. Welcome back. Let's do it. We got to break these roots down. 50 breaks down into 5 and 10, which breaks up into 2 and 5. Do we have a wedding? You bet. These 5s, they get married, become 1, they move out of the house. The 2 is left inside. For 98, that's 2 and 49. 49 is 7 and 7. There's a wedding right there. So the 7s move out, they become 1, move out, and this 2 is left inside. Look! We have like terms. Both the roots are the same, and so therefore we can add them. 5 root 2 plus 7 root 2 is 5 plus 7, which is 12 root 2. Cool. Let's do it with number 9. It's a root 12 and a root 3. We can't combine those yet. We're going to have to break it down. Let's see. 4 and 3, 2 and 2. So here we have a wedding. So the 2 becomes 1 and moves out. Now there's already a 3 out there, so it's like we get 3 times 2 because they became 1 and moved out, and then this 3 is left inside. 3 root 2 is 6 root 3, and 6 root 3 minus 4 root 3. If you had 6 roots minus 4 roots, well, that would be 2 root 3. Nice work. Let's talk about multiplication of roots. We're going to multiply roots now. I am Root. Oh, his name shouldn't be Groot. It should really be Root. That would be awesome for math teachers because we could talk about him all the time. I am Root. To multiply roots, we can do that. You're allowed to multiply any roots together. If you had root 5 times root 7, then yes, you can multiply these together. You would get the square root of 5 times 7, which is 35. So you can multiply insides of roots together. Now, we couldn't do that with addition, Addition, no. But with multiplication, yes, you can. You're allowed to do that. So we can have all types of problems, and sometimes you might do this and you might have to simplify. So for example, if you had the square root of 2 times the square root of 10, we would end up getting square root of 20. We wouldn't find this answer as the final answer because if you remember, square root of 20, that's the one we broke down at the very beginning of class. We end up with a marriage of 2's and a 5 left inside. So don't forget, you might have to simplify as well. We can also end up multiplying roots inside, or having to distribute roots, something like 5 plus root 3. And that's totally allowed. You can distribute into a root just like we would with any other number. I take the square root of 3 in, giving me 5 root 3, and take the square root of 3 here, giving me plus root. I multiply the insides together. Root 3 times 3 is 9. And notice the square root of 9, that simplifies. That comes out to be just 3. Square root of 9 is 3. You could actually say, oh, I got a wedding, nothing left inside. But we know that the square root of 9 is 3. And so that's our answer there. Okay, let's go to the boards again. Give a couple of these multiplication problems a try. Okay, here are questions number 10, 11, and 12. Pause the video and give these multiplying roots problems a try. Good luck. Okay, let's see how you did. We're multiplying roots. We learned that we're allowed to just multiply the inside. So 3 times 15, that's 45. Don't forget to simplify though. 45 is 9 and 5 and 3 and 3. So we have a wedding and we get 3 root 5 as our answer. On number 11, we've got to do some distribution here. I'm going to take the root 3 in. That gets me 4 root 3. And then I take the root 3 in here. That's going to get me 3 root. I multiply the insides. 3 times 2 is 6. There's nothing to simplify here. The 6 doesn't simplify. It's 2 and 3, but there's no wedding. And so this is it. That is the actual answer. Kind of a boring answer. Okay, cool. Number 12. Ooh, now this is like a binomial times a binomial. So we're going to have to use super distribution. Let's try it. Let's go 4 times 4. That's 16. 4 times a negative root 2 would be negative 4 root 2. Okay. 4 times a positive root 2 would be plus 4 root 2. And when we multiply the outsides, root 2 times a negative root 2, that would be negative root 4. On this one, notice that negative 4 root 2 plus 4 root 2, those are gone. These cancel out. I'm just left with 16 minus the square root of 4. Square root of 4 is just 2. And so that one comes out to be 14. It's kind of a tricky one. Kind of cool. If you ever do have an outside number with an inside number, something like 5 root 3 times 6 root 2, you are allowed to multiply these together. You would multiply the outside numbers together. So 5 times 6 is 30. And then you'd multiply the inside numbers together. 3 times 2 is 6. So when multiplying roots, if they've got numbers on the outside, multiply the outside with outside and inside with inside. And just in case you see that. Okay, so up till now, we've learned how to simplify roots. We've learned how to add, subtract, and multiply roots. The last thing we got to talk about is division of roots. Now, I should just let you know that division of roots is not actually allowed. You're not allowed to divide by roots. It's considered one of the math deadly sins. We're not allowed to have roots in the denominator. So, for example, if I were to give you square root of 3 over 2, this right here is illegal. It is a sin. You're not allowed to have a root down in the bottom number. And so today I've got to talk to you about how to get rid of that. If you ever are dividing by a root and you have a root in the denominator, you need to step number 1, multiply the top and bottom by the conjugate. That just basically means the opposite number. Since we just have a single root, we're just going to actually use the same single root. So take a look. I would actually multiply the top and bottom by the square root of 2 over the square root of 2. The reason is that that's going to allow me to get rid of the root. So take a look. What's going to happen is I'm going to multiply the top numbers together, I get 3 root 2. And on the bottom, I get square root. I'm multiplying, and we multiply the insides. 2 times 2 is 4. So take a look. What I've done is, since I multiplied by the same exact root, the root becomes an actual number I know. Square root of 4, well, that's 2. And so my final answer here is 3 root 2 over 2. So we multiply by the same root. It's possible you'll have something different, though. You could have like 4 plus root 3. Let's say that this is what we have. Again, this is illegal. This is a deadly sin because we have a root in the denominator. Oh man, this guy's scary. I should give him some eyeballs and, oh yeah, some curly hair. Okay, no curly hair. Okay, if I want to get rid of this root in the denominator, I got to multiply by the conjugate. The conjugate is the opposite sign. I didn't have to do it up here because there was no sign. But here I have 4 plus root 3. So therefore, I'm going to multiply by 4 minus root 3. I got to do that to the top and the bottom. I multiplied by the conjugate, the opposite sign. Okay, good. Now let's multiply the 5 across. 5 times 4 is, in fact, you could think of this as parenthesis if you really wanted to. 5 times 4 is 20. And 5 times negative 3 is, negative square root of 3 is 5 root 3. So I just took 5 times 4, 20, and 5 times the root 3. I couldn't multiply the 5 and the 3 because the 3 is an inside number and the 5 is an outside number. So I wrote it like that. Ooh, let's do the bottom. Now the bottom, it's like we're multiplying a binomial times a binomial. So super distribute. 4 times 4 is 16. 4 times a negative root 3 is negative 4 root 3. Root 3 times 4 is plus 4 root 3. And then root 3 times negative root 3, well, that's negative root 9. So I'm left with 20 minus 5 root 3 on top. And on the bottom, this stuff cancels out, and I'm left with 16 minus, what's the square root of 9? Oh, it's 3. So 16 minus 3 is 13. And notice, now I have no root on the bottom, and that's my answer. You know you'll have the right answer when there's no root on the bottom. So again, we multiply the top and bottom by the conjugate, and then step number 2 is to simplify. Simplify the top, and then simplify the bottom. Let's give you 2 problems to try really quick on division of roots. Okay, for question number 13, we're going to have you do 8 divided by square root of 6. And on question number 14, we're going to have you do 7 over 3 minus root 2. Go ahead and pause the video, and good luck at the boards. Okay, let's do it. We know we got to multiply the top and bottom by the conjugate. In this case, I'm going to multiply by root 6 over root 6. On top, I get 8 root 6, and on the bottom, I get the square root of 6 times 6 with 36. I know what the square root of 36 is. That's just 6. So I get 8 root 6 over 6. You should probably simplify the 8 and the 6. Since they're both outside numbers, we can simplify those. We can take a 2 out. So I get 4 root 6 over 3. My example previously didn't have a situation where we simplified, but it might happen where you can simplify your outside numbers, and you should do so. On number 14, we got to multiply by the conjugate. I'm going to multiply by 3 plus root 2 to both the top and the bottom. I'm going to put these in parentheses because I want to remember that I need to distribute. I distribute the 7 to get 21 plus 7 root 2. And on bottom, I get 3 times 3, that's 9, plus 3 root 2 minus 3 root 2 minus the square root of 2 times 2, which is 4. And so my final answer is going to be 21 plus 7 root 2 all over, notice this middle stuff cancels out. It's going to be 9 minus square root of 4 is 2, so all over 7. Ooh, this is one that simplifies as well. I was going to say that was my answer. Notice that because we have a 21 and a 7 on the outside, and I'm dividing by a 7, you can simplify these as well. Oh man, I just made this problem up. That's cool. 21 divided by 7 is 3, and 7 divided by 7, that just cancels out, so I'm left with 3 root 2. So it could simplify. Be looking for those situations. It might simplify. Other than that, that's it. We did it. Section 7.2, we studied roots. Good luck on the assignment. Keep working hard. If you have questions, feel free to contact a tutor or myself. We'd love to help.